And let's go ahead and get started. So last class we learned all about radicals and how to simplify them when they were one term, right? Now we're going to get into combining radicals, which means adding and subtracting. So if I have, and there's no new rules, thank gosh, it's using the rules we already know. So 3 radical 3 plus, no, 2 radical 3 plus 3 radical 3 minus 2 radical 4 plus 3 radical 2, right? So the way I like to think about combining radicals is I pretend these are variables, right? Like this is an x and this is an x and this is a y and this one's different, so this would be a z, right? So just like if this was 2x plus 3x minus 2y plus 3z, the only thing we could combine is these, right? So when you're combining radicals, all you can do, and remember this comes to 5x, is you combine what's on the outside and you do not change what's underneath the radical. All right, so if I combine the first two together, I get 5 radical 3 minus 2 radical 4 plus 3 radical 2. So I combined everything that was the same. Now, just like before, we have to make sure things are simplified, right? And if we look at this guy, I can take the square root of 4. The square root of 4 is 2. And because these two things are multiplying, I am going to multiply that as well. So my final answer becomes 5 radical 3 minus 4 plus 3 radical 2. And I can't do anything else because nothing's the same, right? This is my x. This doesn't even have a variable anymore. And this can be my, just keeping my thing as a z. I can't combine those if there were variables. So there, I cannot also combine those if there are radicals. So if you kind of treat them all like that, it I think it makes it a little bit easier reminding yourself you're doing just like you did with variables. You do have to simplify your radicals, but you can only combine radicals that are the same. All right. I don't see nothing in chat, so we'll move on. So what if we have 5 radical 44 minus a radical 99? At first, these things do not look the same, right? But what if we simplify them, right? So 5 radical 44, I can rewrite that as 4 times an 11. And then my radical 99, I can rewrite that as 9 times an 11. All right, this is the rule we learned last class, that you can separate radicals. So the square root of 4 is 2. The square root of 9 is 3. So 5 times 2 is 10 radical 11 minus 3 radical 11, because remember, if there's no coefficient out here, then it is a 1. And 3 times 1 is 3. Now, I have what's under the radicand. They're the same. So therefore, 10 minus 3 is 7 radical 11. All right, still no questions, so good. So what if we have the square root of 8x squared all over 5y minus the square root of 18x squared all over 5y So we simplify this. 8 is not a perfect square, but 4 times 2 times x squared all over 5y minus the square root of 9 times 2 times x squared all over 5y. And take the square root of 4, that's 2. Can't take the square root of 2, take the square root of x squared, that is x. Take the square root of 9 is 3. Take the square root is x. Remember, there is a 1 in front of both of these because there's no numbers out there. So this becomes 2x square root of 2 over 5y minus 3x square root of 2 over 5y. What is under the radicand is the same. So 2x minus 3x is a negative x square root 2 over 5y. Give that a second, we're going to look at. All right. Nothing in the chat. So skipping ahead for a second. That's related to all of the add and subtracting. We'll do some more here in a minute, but I'm going to combine the next two, talk about multiplying and dividing radicals, and then we'll go bring this all together at the end. So when we multiply and divide, if I have 2 radical 7 times 3 radical 14, again, if I treat this as a variable, right? If this was 2x times 3y, my answer would be 6xy. Notice we do multiply our variables. So we do the same thing with our radicals. This becomes 2 times 3, and then a square root of 7 times 14. Well, 2 times 3 is 6. 7 times 14 is 98, so that is under the radical sign. Now I do have to see if I can simplify this, right? Well, 6 square root of 98, that equals 6 square root of 49 times 2. The square root of 49 is 7. Can't take the square root of 2. So 6 times 7 is 42 radical 2. All right. So what if we have 2, eraser on. Now, come on, eraser. 2 radical x times radical 15 minus 3 radical 3, right? Again, we use our distributive property, so I'm going to distribute that through the parentheses. So 2 radical x times radical 15 becomes 2 radical 15x. And then 2 times negative 3 is 6. And then radical x times radical 3 is a radical 3x. All right. Now, we have to be careful with here. If you look at 15, I can break him down to be 5 times 3x, right? And these things both have a 3x in them. However, because I can't take the 5 out, they are not the same, so I cannot do anything. So even though they're kind of similar, they have to be exactly the same to do anything. So my final answer is 2 radical 15x minus 6 radical 3x. They have x's, but if they're not exactly the same under the radicand, then I cannot combine them. I can't break the 15 apart. So this is my final answer. Now, last class, we talked about rationalizing the denominator, right? Rationalizing the denominator, which means do not leave a radical sign in the denominator. So if we have the cube root of 4ab, and we're dividing that by the cube root of 2a squared b to the 4th, right? I can put this all together. No, actually, no, I can't. We're going to rationalize first, right? And so what we did last time is we multiplied the denominator by the exact same thing to cancel out the radical. This one's a little more challenging because it is not a square root, it is a cube root, right? So I have to remember, tell myself how to get rid of a cube root. The radical sign of a cube root is to make everything underneath it a perfect cubed. Well, how do I make 2 a perfect cubed? Well, I need 2 more 2's. So if I have 3 2's, then I can take the cube root of that. Well, 2 times 2 times 2 is 8, so I need to multiply this by a 4. 4 times 2 gives me the 8. And it's a cube root. To get rid of my a squared, I need another a, because if that was a cubed, I could take the cube root of it. So if I'm only missing one a, I can multiply it by an a. B to the 4th, I can take part of it out because it's greater than 3, but I can't take all of it out. So to get from b to the 4th, so I can take the perfect cube, that needs to become b to the 6th. So then I have to multiply this by a b squared. Now, what do I do the bottom? I have to do the top. And the reason, again, we can do this is this entire thing just equals 1, right? If I have the same numerator and the same denominator, that equals 1. So I'm not changing the problem by multiplying it by 1. I'm just making what we learned a little beginning of chapter 6. We're making an equivalent fraction here. So if I multiply these together, now I get my perfect cubed on the bottom, because 4 times 2 is 8. A times a squared is a cubed. B squared times b to the 4th is b to the 6th. Remember our rules, when we multiply bases, we add the powers. And then when I multiply the top, I get a cube root. 4 times 4 is 16. A times a is a squared. B squared times b is b cubed. All right. Clean up my writing here a little bit. So now, I know my denominator is a perfect cube. That was the whole point of doing it, but I would double check my work. So the cube root of 8 is 2. The cube root of a squared is a. The cube root of b to the 6 is b squared. Because remember our trick we learned last class. Take that number, put it in the denominator. 6 divided by 3 is 2. Now, if I take the cube root of the top piece, cube root of 16 I can't do, but I can go and make this 8 times 2. I can't take the cube root of a squared. He's stuck inside. And how I know that? The 2 is smaller than the 3. Cube root of b cubed is b, so I can pull him out already. Now, I can take the cube root of 8, which is 2. Everything else is stuck inside. So I now have 2b cube root of 2a squared all over 2ab squared. Now I can simplify. This 2 and this 2 cancel. This b and one of the b's cancel, so I have just a b in the bottom. So my final answer to this whole ugly process is the cube root of 2a squared all over ab. So a lot of steps. So you definitely want to take your time and look through these, because it really can come down to just making small mistakes somewhere. So just take your time. Now, do you have to do all the steps I did? Of course not. But I did it in one little step at a time so you could see through the entire process. So key takeaway, multiplying, dividing. All we need to do is get things to multiply and divide to each other. Adding and subtracting, we have to make sure what's under the radicand sign is the same. Okay? Any questions on anything we've covered so far? Check my chat. Chat's quiet. All right, we're going to do 2 more problems. One tricky one, kind of that brings everything together. And then we will let's see what other, if anyone has any questions then. So, what if I have 3 minus 2 radical 2 all over 2 radical x? Right? So, can't do anything with this as it is right now, but I can rationalize the denominator. And so since this is a square root, I can multiply this, what I multiply, not 2 radical 2, 2 radical x times 2 radical x. I technically don't have to multiply it by the 2, but if it just helps you to do it the same way, you can. It'll just be more stuff to simplify. We can actually just multiply this by radical x, as all I care about is what's under the radical sign. So either way works. I'm going to do it this way to simplify some of the math. So 2 radical x times radical x is 2 radical x squared. Now I have to distribute that through everything. So I put it in parentheses to remind myself. So this becomes 3 radical x minus 2 radical 2x. Now I can simplify my denominator. So the square root of x squared is x, so this becomes 2x. And I have 3 square root of x minus 2 square root of 2x. Again, these are close, right? Because they both have x's, but they have to be exactly the same. So therefore, I cannot do anything else. And that is the final answer. Now, if you multiplied everything by 2 radical x, then you would have had to simplify because we would have had a few too many 2's. All righty. We ready for a challenging one? I'm going to try to go neat and slow on this one because when you start to deal with things that are a polynomial, things can get a little tricky here. So what if I have 2x plus y to the negative 1 all over, raised to the negative 2 power. Right? So what I would do here is, remember this negative flips it. So I'm going to do this in steps, because if you try to do too many at once, it can not look good at first. So this first becomes my eraser keeps kicking on, 2x plus 1 over y to the negative 2, which then equals 1 over 2x plus 1 over y squared, because this negative moves everything to the bottom. Now I want to FOIL this thing. So I get 1 over 2x plus 1 over y times 1 over 2x plus 1 over y. And if we multiply these things together, 1 times 1 is 1. So the numerator is the easy part. And now we have to FOIL. So first, I get a 4x squared. Then my outer, so 2x times 1 over y becomes 2x over y. Now do my inner, and I again get a 2x over y. And then 1 over y times 1 over y is 1 over y squared. So all we did here was FOIL. And all we did in the top part was use the negative exponent rule. So now if we combine terms, we get, again, 1 is my denominator. I get 4x squared. 2x over y plus 2x over y, right, becomes plus 4x over y plus 1 over y squared. Now, before I can add these things, I have to get a common denominator. Well, he has a y squared, he has only one y, he has no y. So my common denominator here is going to become a y squared. Well, that means he was missing a y squared the whole time. He was missing just a y, and he was good. So this whole thing now equals 1 over, trying to make sure I don't mess all this up, 4x squared y squared plus 4xy plus 1 all over y squared. I'll give you a sec because I want to go to a new page to kind of write this down. All right, nothing in chat still. So I'm going to rewrite this again on a new page. So again, we had 1 all over 4x squared y squared plus 4xy plus 1 all over y squared. Well, another way I can write this is treat this first one here as a division sign. So this becomes 1 divided by 4x squared y squared plus 4xy plus 1 all over y squared. I'm going to take my 1 and make him a fraction. So now I have a fraction divided by a fraction. Well, if I do that, the rule of dividing fractions, which was back in chapter 6, is I flip the second fraction. So I now have 1 over 1 times y squared all over 4x squared y squared plus 4xy plus 1. And 1 times anything is itself, so therefore that is my final answer. The good news is that's as ugly as they get. I doubt there'll be anything like that on the test, but I don't know for sure. I haven't written it. But I like to show that problem because it brings basically everything we've done in chapter 6 as well as chapter 11 together. And you can kind of see how all of this goes together in solving challenging polynomials, or simplifying in this case, there's no equal sign. So that's basically the end of chapter 11. Next week we'll start chapter 13 and do a few sections in that, and then actually we'll end our course. So today, like I said, is definitely a shorter day, but this gives time for anyone who has questions on anything we've covered so far, or wants to talk about anything. I can, but I don't have really anything else unless you just want me to keep putting up practice problems and going through some practice problems, but I'll let people decide what they want to do.